Hello everyone. Today we are going to talk about another topic or another concept that is related with transformations. And this one is rotation. I'm sure that every one of you have used this tool, the spinner, or this one when you played, when maybe you are playing with it now. So what these objects do are rotate according to a given center. Okay, so according to the center, this object will be rotated. Same thing with this one. Okay, it will be rotated according to the center. So this one is rotation. Rotation is a turn. Well, to understand it better, you have to do this activity now. You will draw a rectangle on your notebook. Okay, you can draw a rectangle like this. Then you'll one of the vertices you will make as your point. Okay, the same rectangle you are going to cut as a paper. Then when you put the rectangle that you have cut it on your original rectangle, you can rotate it according to this point. Okay, and you'll see how the rotation is performed. When you make a 1/4 turn, okay, it means 90-degree turn, the object will come like this. So you have to try this one in your home to see how the rotation is performed. I can try one of them. I have taken the rotation, the center. Okay, so the center of the rectangle is the rotational center for me. And if I move this one, if I rotate, you'll see how it moves. Okay, but the shape, the length of sides, the angles are not changed. So this one is 1/4 turn or 90-degree turn. So only the position of the object is changing. Everything else is same. Okay. So this one is 108 turn. And if I go here, it will be 360 turn. So we can turn or we can rotate the objects according to a given center. Don't forget, to a given center. And the rotation, you know, or turn is performed by degrees. Another concept that we are going to talk about is rotational symmetry. What is rotational symmetry? A shape which fits into the same position more than once when rotated through 360 degrees has rotational symmetry. So if I have this rectangle, if I rotate this rectangle according to this point, okay, I will see that after 1/2 or a half turn, the rectangle will take the same position with the original one we tried before and you saw. So this one means it has a rotational symmetry. Okay, so the object can fit in the same position more than once when you rotate through 360 degrees. We can understand it better. So let's have a look on these animations. It is given this shape and it said that it has a rotational symmetry. So as you see, when you rotate, it goes to the original position. Okay, so it comes to 360 degrees in the same position. With this one, so this point show me the rotation, okay? And this one, how many times it fits? Okay, so once, twice, 3 times. So it comes to the original place in the same way. So this one is rotational symmetry. Okay, just to have the idea about it. Now, as we can see the examples that are given on the book. For example, the letter A, the capital letter A. If we rotate the capital letter A, we see that it won't fit to its original position until it goes 360 degrees, the full turn. So we'll see that it has no rotational symmetry. But the letter H, if we rotate it step by step, we'll see that at half turn, it will have the original position. You can continue again, and the full term, it will come again to the original position. So H has a rotational symmetry. You can have a look on the other examples on your book too. Now we can pass to how to perform rotation to a given point, about a given point. Well, to perform rotation about a given point, we'll need the center of rotation. We'll need how many degrees the rotation is performed, the direction of the rotation, and of course we need the tools. So if I have angles, I will need a protractor, okay, and my pen. So to perform these ones, we'll need the protractor. Okay. So let's make it a bit smaller. Now, it is given this triangle. I want to rotate this triangle 90 degree anti-clockwise. Anti-clockwise means in this direction, opposite clock, okay? About the center O. So first of all, let's name this triangle. O, let's say this one is A, the vertex A, and this one is the vertex B. Now, if I want to rotate the point O 90 degree, it means I'll put the protractor here and I will see where the angle 90 degrees form. Since O is the center of rotation, it means it won't change. It will be in the same position. To find A, okay, I will center my protractor on the O, the center of rotation. OA is the side, one side of the angle that I'm looking for, and the other one will be 90 degrees. So A will be in this line, okay, in this direction. The length of the sides must be same. So since A is here 3 squares, it means A will come here 3 squares. So let's say this one will be A1. The same thing we'll do for OB, now for point B. So I have to measure the angle from the center O, okay? So OB is here, 90 degree, anti-clockwise will be in this direction. So B is in this line. And since B is 4 square away from O, again it will be 4 square away. So let's plot the point B. 1, 2, 3, 4. So it will come here. Let's say this one is B1. Now we can join the points. Okay, let's join the points. So this one is the rotation that is performed 90 degree anti-clockwise. The same thing can be performed from the rectangle that is given. Well, I will draw one more time the rectangle because okay, let's draw the rectangle here. So it is 4 and 2. Okay, so I have this rectangle. Okay, this is my rectangle. The center of rotation was again this point O here. Again, I want to name the rectangle. Let's say this one is the point A, B, and C. Now the same steps we have to follow for these ones. From the center O, I have to find or I have to send A 90 degree away. So we have to measure the angle from OA 90 degree but anti-clockwise. So we have to be careful with direction. It means I have to find the angle on this direction. Okay, so no in this one, but in this way. So 90 degree, it will be here. So A will come to this position. Okay, A will come to this position. So A1, since it is 4 squares, again it will be 4. A1 will be exactly here. A1. The same thing we can complete for the other side. So I will go at B. 90 degree, it will be in this direction. Okay, here it is 90 degree. Okay, in this direction, the distance must be kept same. So the point, okay, it was this direction. Distance will be here. So here I will have B1. Same thing for C. Okay, in this way. So angle 90 degree is in this direction. It is 2 squares away. So point C will be in this direction here. Let's plot point C. It is 2 squares. So here I will have C1. Now we can join the points. Okay, so this will be the rotated rectangle. As we said, the direction is important. If it will be clockwise, so let's draw here the clockwise direction to look it clearly, the difference. Okay, so if I want to draw clockwise, it means clockwise is in this direction. Okay, so A will come here, 90 degree. Let's plot A, let's make it green. So A will come here, let's say A2. Okay. Same thing for B. So it is clockwise, so it will come in this direction. 90 degree is where? It is here. So B must be in this direction. Okay, here. At 90 degree. Put it right. Okay, so B is here, 90. Let's put B. B2, let's say. Now we have to measure for point C. So OC, C 90 degree, since it is clockwise and in this direction, will come here. So we can put point C here. And if we join all these points, we'll have the rotation. Okay, so we can write this one. So this direction is anti-clockwise. Okay, and this direction, it means when it comes here, it is clockwise. So these ones will be the two rotations. In the same way, we can have other looks on the exercises that are found on your book. I want to solve this one too. At C, it said that this figure will be turned or rotated 180 degree clockwise above the point O. To turn 180 degrees is more easy. We can even not need the protector, only a ruler. We can do it because we know that 180 degrees what is a line. Okay, so it is not so difficult to turn it. Let me draw one more time this shape. So I have 3 squares in this form. 2 again, 3. Okay, so this one is the shape. O is found here as a point. Here is point O. Okay, now we can rotate it. Clockwise means in this direction. So first, okay, in this direction will be the rotation. Now each vertex of this figure have to be rotated 180 degree. Okay, I have 5 vertices. So as I said, directly with a line, okay, we can see this rotation. So if I take this point here, it will go in this direction. It means it will come here. The distance must be kept same. Okay, the distance must be kept same. So since it is 3, 1 here, it will come here. Okay, 180 degree. If you measure, it is a line, we said. So this point will come here. Let's name A1. B, C, D, and E. Okay, in the same way, we can continue with the other lines. Okay, so point E, 180 degree clockwise, it means in this direction, will come here. Point B, again, it must pass through point E, will come here. Okay, the direction is 180, the distance must be same. Let's put this ones first. So I have E1, and here I will have the point B1. Then this point, again 180 degree clockwise from O. Okay, it will come in this direction. It is here. And this point, okay, 2. So it will come here. Let's name them 2. C1 and here D1. Let's join those points now. Okay. So A is joined to this point, this one to this one. Okay, so as you see, this figure now is rotated 180 degree clockwise. Okay, so 180 degrees is too easy. Just draw the lines. Okay, that's all for today. You can look the exercises on the book and you can practice. Now I want to show you one animation related to rotation. So here it is given an example. This triangle will be rotated according to this center with 90 degrees. So let's see how this rotation is performed. So first of all, the angle are measured, okay, from the center to each point, as you see, and then the figure is rotated. Okay, we can take another angle. Let's make it 180 degrees. As you see, in a line that goes. Okay, let's make it 270 degrees. Okay, let's start it now. So 270-degree angles are measured from each point. Okay. Now let's take a smaller angle. Let's say 30 or 50 degrees. Okay. All these rotations are anti-clockwise. Okay. So the rotation is performed like this.